Hi. Music analysis is one of the most important skills that you can have as a young musician, whether you're trying to learn the pieces you're studying better, or learning the styles of the great composers, or just understanding music in general more completely. But a lot of my students struggle with the basic skills of analysis. So I've made a series of videos that try to address this. And this first video is on how to find the harmonic roots of triads and seventh chords quickly so that when you're doing analysis, you don't have to spend a lot of your time transcribing things and making additional notes. So I hope you find it useful. Stay tuned for more on this topic. One of the most important skills that analysts need to have, especially when trying to understand the harmonies of common practice music, is the ability to find roots of triads and seventh chords quickly and accurately. In order to do that, we need to review very quickly a couple of things about the intervals that are used to make up chords. So all intervals have a quantity, and that's a number that you get by counting the lines and spaces between two notes on the staff. And you have to make sure that you count the lines and spaces occupied by the notes as well as the lines in between. Now, intervals also have a quality, and you determine that quality by comparing a given interval with the notes you'd expect in the major scale built on the lower note. But for today, we don't really need to worry about that very much. That'll come up later. The last idea that we need is interval inversion. So an interval is inverted when the position of the lower and higher notes are reversed. And this often happens by either transposing the lower note up by an octave or the higher note down by an octave. Here on the left-hand side of the screen, you can see some fifths. They're marked with these red brackets, and these fifths, you can see, are 1, 2, 3, 4, 5 lines and spaces apart. Same thing here, 1, 2, 3, 4, 5 lines and spaces. If you're looking for a nice, easy way to identify fifths quickly, it'll always be true that a fifth is either two notes in spaces, separated by a space, or two notes on a line, separated by a line. Now on the right-hand side of the screen here, what I've done is simply inverted these fifths to become fourths. So I've taken the note off of the bottom and I've simply transposed it up to the top. Now it's always true when you make an inversion that the number of the original interval and the number of the inverted interval sum to 9. So if these intervals here are fifths, then these over here are all fourths. And you can verify that by counting the lines and spaces in between them. Now these fifths and fourths are going to be really, really important in helping us find harmonic roots. So you want to practice finding them quickly. You can write them down. I don't have a clef here because it doesn't make the slightest bit of difference what clef we're in. We always see the same things when we see fifths and fourths. Now over here, I've given 3 rows of triads, all in close position, so all the notes are within an octave. First row has root position triads. Okay, they all look like snowmen. The second row has first inversion triads. You can see the gap between the top note and the lower two. And then we have second inversion triads in the last row, and you can see the gap between the top 2 notes and the one on the bottom. All root position triads are going to have a fifth between the root and fifth of the chord. Okay, so I've marked those in red here. And most people have no trouble seeing those. When you invert these triads, you take the note from the bottom and you simply move it up to the top, which leaves you with a series of fourths. Okay, and these fourths are both in the first inversion triads and in the second inversion triads. Now what you need to remember is that if you see a fifth, the root of the triad is always the lower note of the fifth. But if you see a fourth, the root is the upper note of the fourth. Same thing is true for second inversion harmonies. These roots are always the upper notes of the fourth. And although you see these triads written in close position most often in theory books and exercises, you'll see them a lot in piano music sometimes in guitar music, and so it's good to be able to recognize them quickly. More common than closed position triads is seeing triads in open position, and those are triads whose notes are stretched out over one or more staves and one or more octaves. But even when the triads are in open position, we're still looking for the same things. We're still looking for fifths and fourths. Okay? So in the triads that you see here, I've identified in red the fifths and fourths. And it's always going to be the bottom note of the fifth or the top note of the fourth that's going to give me the root of my chord. So here I have a fourth, which makes this D on top my root. Here it's a fifth, so the root is B flat. And I can identify my roots quickly by simply finding the fourths and fifths and taking the upper note of the fourth or the lower note of the fifth. And that gives me all of my roots that are circled here. Now, when we look at seventh chords, we have a different set of intervals. We have sevenths, which invert to become seconds. And when these are present, these are going to override the fourths and fifths in terms of telling us whether we're dealing with triads or seventh chords. And we're going to use these sevenths rather than the fourths or fifths to find the harmonic roots. So, just to review, these are sevenths because counting the lines and spaces between, we have 7. And just like fifths have a visual pattern, sevenths also have a visual pattern. They will both be on spaces with 2 spaces in between, or both on lines with 2 lines in between. Okay? Inversions of sevenths become seconds, so that the seventh and the second sum to 9, just like we saw when we inverted fifths to become fourths. So here you see root position, first inversion, second inversion, and third inversion, seventh chords. In root position, you have these sort of giant snowmen, always bounded by sevenths, which makes the root always the lower note of the seventh, and that's probably the easiest way to see that. But in all the other inversions, first inversion, second inversion, and third inversion, those sevenths become seconds. And what you're always going to be looking for here, once you've found the second, is the upper note of the second is going to become the root of your chord. So finding that second and taking the upper note as the root will make it very easy to see what the harmonic roots of these things are. Just like triads, seventh chords can appear in open position as well, stretched out over more than one octave and on one or more staves. But you're still looking for the same thing. You're looking for seconds and sevenths. If you see a seventh, it's the lower note that's going to become the root. If you see a second, it's the upper note that's the root. So I've identified them here in green. You can see that this first interval is a second that itself has been stretched out over more than one octave, but that leaves us with the root on top. Here the seventh gives us the root on the bottom, on the bottom, on the bottom, on the top with the G sharp, on the bottom here with the A flat, and on the bottom here with the A. Okay? So if it's not yet comfortable for you to be identifying these roots in open position, the first thing that you want to do is write out a whole bunch of triads and seventh chords in closed position and then expand them onto 2 or more staves into open position and make sure you can find the roots. Now, when it comes to analyzing real music, which is, after all, the whole point of why we're here, a couple of things you're going to want to keep in mind. Point number 1, in all cases, it's the sound of the music that's important, not so much what it looks like. So make sure that when you're dealing with a passage or an entire piece, if you can't hear it in your head when you are looking at the music, find a recording, or better yet, sit down at the piano and play through it. Even if your piano skills aren't great, it's going to help you to understand the music much, much better if you can hear it. In many instrumental textures, the triads and seventh chords we're looking for are broken up into different patterns, and they don't always appear as vertical stacks. So you're going to want to look left to right or horizontally as well as vertically to try to find these intervals. In real music, sometimes the fifth is omitted from triads, and when that happens, you're going to end up with no fifth or fourth to look at. Usually the musical context will help you decide whether the remaining third that you see is the root and third or third and fifth of a chord. Singing or playing the passages both ways will help you make a decision as to which sounds better. Sometimes in real music, you'll get passing tones, which are notes that aren't part of the harmony, and they can look like sevenths or seconds. If they're moving by step before and after, it's usually acceptable to treat them as non-chord tones, but if the suspected seventh is approached or especially left by a leap, you're going to need to treat it as a chord tone. The best place to begin practicing these skills is to start with piano music. Fairly simple piano music, sort of intermediate level student music, is a great place to begin. If you have an anthology of analytical excerpts, there should be lots of music in there to look at. When you feel ready to move on to orchestral music, it's probably best to start in piano reductions for one piano or two pianos. When you begin to look at orchestral scores from the classical period, focus mainly on the string section. Okay? The winds and the brass section usually are treated by color by composers like Mozart, Haydn, and Beethoven. So if you can train yourself to look first at the strings, you should be able to get all the information you need about harmonic roots from those. As always, IMSLP is a great source for music to analyze. All right, so let's begin to try to apply some of these skills to a couple of pieces of real music. First, we'll look at the C major prelude from Bach's Well-Tempered Clavier, Book 1, and we'll look at just a passage, the first 11 measures up to here. I'm going to keep the color coding the same as we had in the other part of the video. So when we're finding fifths and fourths for triads, we'll be using red, and when we're looking for seconds and sevenths to find seventh chords, we'll be using green. So here, the beginning between the C and the G, there's a fifth, which gives us a root of that bottom note there. You can see the second right here, which gives us a root on the upper note. It's a little harder to see the seventh there, but that gives us the root on the lower note. Then we have, again, the fifth giving us the root on the lower note there. The next measure, the fifth is here, so the root is here. Measure after that, we have a second, giving us the root on the upper note. After that, we have the fifth here, the root on the lower note. Another second here gives us the root on the upper note. A little harder to see, there's a seventh right there, giving us a root on the lower note. Then we have a seventh here, giving us a root on the lower note. And finally, we have a fifth here, or fourth there, giving us a root on the lower note. So from this, we can see that there are harmonic roots on C, D, G, C, A, D, G, C, A, D, and then our cadence here on G. Now we're not yet concerned with the quality of any of these harmonies or the kind of Roman numeral analysis that you might use later on. We're just trying to find the harmonic roots quickly so that we can get a sense of how things basically work. Let's look at a slightly more involved example here. This is a two-piano reduction of the second movement of Beethoven's Fifth Symphony. And here we're going to have to make some judgment calls about certain things. At the beginning, you can see a triad in broken form, so that the fourth there gives us that root on the A flat, which is the same as the A flat down there. But in the next measure, the D flat and the F, well, that's only a third. So we don't know whether the D flat is the root of a D flat F A flat chord, or if it's the third of a B flat D flat F chord. If you play through it, you'll find that the root is much more convincingly D flat. Okay. In the next measure, we have this fifth here between the G and the D flat, so that's going to be our root. Next measure, again, we have a fifth between C and G, so that's our root down there. And we can treat this B flat here as a kind of passing tone if we want. Measure after that has only an F and an A. So FAC is much more convincing than D flat FA natural, which would be an augmented triad. So we'll take the F as our root. B flat and D, our root is B flat here. In the next measure, our root is E flat for the same reason, then A flat. And then we have our cadence. Here we only have an E flat, so we'll take it as a root. And then the A flat there, which we'll take as a root as well. So when we look at it that way, we can see a kind of interesting pattern happening here. We have roots on A flat, D flat, G, C, F, B flat, E flat, and A flat. And that unfolds the entire circle of fifths, the diatonic circle of fifths in A flat major, and it gives us a really good sense of what it is that Beethoven is thinking as he creates this pattern. And you can see that the harmonic rhythm of the chords is 1 per bar in the first 4 measures, and then it accelerates here towards this authentic cadence in A flat. Last example for today, even a little bit more complicated. This is some music of Haydn. This is from Symphony number 93 in D major, and this is the sort of second theme. Now we're going to be looking primarily at the string parts here, okay, because the string parts are where you find most of the information that you need. String parts in scores are always located on the bottom of each system, and they're bracketed together so you can find them pretty easily. One thing you have to keep in mind working with string parts is that you're going to need to become pretty good at reading alto clef. That's the clef for the violas. So if you need help with those C clefs, use an online tool like you can find at tonesavvy.com or any other one that you like to get good at this. But it's usually possible to bypass the alto clef if you're trying to work quickly. So we're going to start right here. And at the beginning of this second theme, we see a fifth, giving us a harmonic root on A. The next measure, we can see a second there, which gives us a harmonic root of E, the upper note. And then back to a fifth, and a second, and a fifth, and a second, and a fifth here, and a little harder to see that seventh there, but that gives us the root. And then back here to a fifth, sort of eventually with that E up there. And you can see that what Haydn is doing here is creating a theme using just 2 roots, the local tonic A and the local dominant E. And he's simply moving back and forth between these 2 roots, creating stability for the A by using a simple triad and instability on the E using a 7th chord, so that he's able to create these small patterns of tension and release, tension and release, tension and release that really pushes this theme forward. So on the one hand, it's a very simple kind of construction, but very elegant in the way that it's worked out. So when you look at your own pieces of music, whether it's piano music or orchestral music in piano reduction, begin by looking at works from the 18th century, music of Bach, Mozart, Haydn, and early Beethoven. It's not so difficult to move into the early 19th century with pieces like Schubert, but when you get into the mid part of the 19th century, finding the harmonic roots of these progressions becomes a little more challenging. So make sure you're working on the easier, more straightforward stuff. First, before you push into more adventurous territory. All right, have fun, keep practicing, and I will see you next time.